Hello everyone, this is our problem longest night subarray. This is PUTD of 18th March, and in which you have to given a integer array nums of positive integers, and we can call a subarray of nums nice if bitwise AND of every pair of element that are in different position in the subarray is equals to 0. So we have to return the longest length of nice subarray. So you have to given a subarray. What is subarray? Subarray is basically a contiguous part of an array, and that the subarray of length 1 is always be considered as 1. Means if there is only one element in my subarray, let's suppose 1, so this is always be considered night. So minimum length of our subarray will be 1 in all the conditions. And this is our example given, in which our nums given 1 3 8 48 10 and length given 3, that is 3 8 48, and they are given and between 3 and 8 0, 3 and 48 0, 8 and 48 0. Okay, the constant of our problem is 1 nums of length is equals to 1 equal 5, and nums of 5 is less than or equals to 1 into 10 to the power 9. Okay, so let's understand the question with the first example. Okay, this is our example 1 3 8 48 10. So since you have to find the length of longest length of the subarray which in which all the pairs and is equals to 0, means like if pair, if I can write pair, yeah, pair, let's suppose pair A comma B comma C, then let's may increase the size, then A and B is equals to B and C is equals to C and A should be equals to 0. So this is our condition for the nice subarray, and we have to find the longest. So as we know that and in AND operation, if bit is 0, if one bit is 0 and other bit can be 0 or 1, then result will always be 0. So if one bit is if one bit is 0, so result always be 0. So since it is a in this problem, you have to find the and of you have to find the longest subarray whose pairwise and equals to 0. So for that you have to find the elements whose bit should be differ at every position. Like if given two element A and B, let's suppose two element A and B. So for and of A and B to become 0, so each bit should differ at every position. So let's take the example of 1 and 3. So the bit of 1 is equals to 0 and 1, and the bit of 3 is equals to 1 and 1. So as we know, as you can see that each bit is not different, like here 1 and 1, so it will be become 1 and it will be become 0. So result will not be 0. So the approach we can build that for two array to become two, so for two integers their and should be equals to 0, so they should be differ at each and every digit. So in this problem we say the problem saying that each each pair should have and equals to 0, means if we are considering this subarray, so this pair, or let's suppose this pair, this array should be equals to their end should be equals to 0. So for and should be equals to 0 of 3 and 48, they should also differ on each and every bit, and 8 and 48 should also differ on each and every bit, and 3 and 8 should be differ at each and every bit. So the approach is coming into our mind that we are using a sliding window in which we run a loop from we first initialize I from here and j from here. Okay, then we go to the end. What we actually want that let's make a table of counting the bit in every position. Okay, so our approach would be look like this. This is our bit. So let me make this table. So let me make the table. This is in which we represent bit. So this is 0 bit, this is 1 bit, this is 2 bit, this is 3 bit, and this is 4th bit, this is 5th bit. So what I will do, first I will push an integer, that is jth integer, and I will just increase the count of bits that are set in my current nums of j. So first I am standing at the first index. So what I will do, I will just go to 1 and each and every bit of 1, since in 1 only first bit, that is 0th bit is set, so I will increase the count, that is 1. Then I will check that if in my subarray I will check that if my prefix this prefix array, if any bits having the bits number, like having the count greater than 1, means they means in my subarray that is from I to j, there is an integer that have the same number of bits at any position. So then I will go to the third, and then if I go to third, then I will increase the count. So 1 become 2, this will become 2, sorry, this will become 2, and this will become 1. Since we know that if any bit count will be greater than 1, means this means end of the two number in that subarray will not be equals to 0, because they are not differing at each and every bit. So what I will do, I will just remove this 1, because as we know that we cannot make a because we have to go to the right side, and since these two are not have and equals to 0, so we have to remove 1. So I will just remove 1. After removing 1, yeah, after removing 1, our array will be look like this. Then I will go to the 8. 8 is represented in the binary like this. So this is the third bit that is set in the 8. So I will say just set 8, and since in my this subarray there is not any bits where the count is equal to 2, so then I will go to the next element, that is 48, and since 48 is represented in my binary number like this, 32, then 16, then 0, 0, 0, that is 8, 4, 2, and 1. Okay, 48 is represented by this in my binary, so I'll just increase the count of 48. This is here, this is here, and since there is not any single bits where our count is greater than 1, means each and every number in my subarray have not have any common bits where where the number is set. So I can take this subarray length. So the subarray length will be 4, that will be 3. Then I will go to the next element, that is 10, and 10 is represented in binary like 8 and 0. So 8 0 1 0. So this 1 will become 2, and this 3 become 2. Okay, so I found that in my prefix array, we can say that count array. In my count array, there is two position where two numbers are not differing at each and every bits. So uh, so there and will not be equals to 0. I will not take this length. What I will do, I will then try to remove, uh, since this become 2 and this become 2, so I will just try to remove the number from my left index, that is ith index, that is here. I will try to remove this. The first I will remove the third. When I will remove the 3, this will become 1, like this. It will hurt, this will remove, only 1 will be set, and I will just decrease the count, so 1 and 0, because in third these two bits are set. After that I am finding that there is even there is one bit where my count is greater than 2, greater than 1. So what I will do, I will remove 8 from my array. When I remove 8, then this will become 1, and my array look like something. My array will look like something this: 1 0 1 and 1 and 1. Since it is having the every bits less than or equal to 1, so we take the length. Length will be our 48 and 10. That will be length of 2. So since we already found the length of 3, that is maximum than the 2, so we go to the right, but we are standing at the last index, means we cannot go to the right of my array, so we just return the length, that will be 3. I hope you understand my approach. Let me take another example. Let you can make your approach what I am saying basically. So in this example, I will just start with I, that equals to 0, and our j, that is equals to 0. Then I will make a array that will be size of 30. So I will make a array that will be size of 30. So I will make a survey that will be size of 30, and let's suppose this is my array representing the bits basically. Since it is given that maximum number can be 1 to the power 9, so we can say that 30 bits will be enough. So let's suppose this is representing my bits count. Okay, so this is my 0th bit. Okay, sorry, this is my 0 bit, this is my 1 bit, this is my 2th bit, this is my 3rd bit, this is my 4th bit, this is my 5th bit, like this. So I will go to the A, that is my jth element, and I increase the count like this. I will go to the B, I will increase the count like this, and I will go to the C, I will increase the count. Let's suppose C has a set bit here, so this will become 2, this will become 1. Since we found that our bits count is greater than 1, means there is a number, there is 2 number in my subarray whose and cannot be 0, because they have matching bits. So since they have the matching bits, their bits cannot be 0. So we cannot take such subarray. and we have to discard it. So I will go to the first, I will go to the ith element, that is my here, and standing at ith. I will just try to remove I. So if I remove I, so it will become 0. Then we increment the I, go to this element, bth element, and we try to remove the count of b, that makes 1 and 1. Since I found my array now containing only 1, so I is standing here and only one element is my array, so we can say that the answer, since we already taken that a and b and their bit is they are differing at each and every bit, so our answer is already 2, and we cannot take this element, so our maximum answer will be 2. I hope you understand my approach. My approach is simple. I make the count array that will be size of 30, and I will just increase the count by running the loop of 0 to 30 and each and every bits. So for array should be nice subarray, our counts bit at each and every position should be less than or equals to 1. Like if I take the element of k, if I take the k elements in my array, so each and every bit from 0 to 30 should have the count less than or equals to 1. If count will be greater than 1, means there are two elements, at least two elements whose and is not 0, so you cannot take this element. So I think you understand my approach. Let's try to code it. Okay, this is Leetcode editor. Let's try to code the approach. Okay, I will make my answer that since minimum answer will be 1, so I will just initialize with the 1, and I will make count. I will take I is equals to 0, j is equals to 0, and I will make a count that will be size of 30, 0, and I will run a loop while j less than n. Okay. What I will do, I will go to each and every digit of, I will go to each and every bits of my nums of j, and whenever my nums of j is set at that bit, then I will set that number in my, I just increase the count of that bits by 1, so I will do count plus plus. Okay, and before that I will just taking a boolean f is flag, that will be first will be false, and if our count will be greater than 1, so I will just mark that our flag equals to true. Like we find any bits where count is greater than 1. So what I will do, while f, and means if our count containing the two element whose and is not equals to 0, so I will run a loop that go to each and every bits. I will make the f equals to false because I am doing operation once. So I will go to each and every bits of my nums of I, and whenever nums of I having the any set bits, I will just decrease the count of k, that will be minus minus, and if even after decreasing my count of k is greater than 1, so I'll just make f equals to true, because means we have to again discard element. I'll just do here I plus plus, since this loop eliminate all integers whose pairwise bits is not 0. So after that we know that after traversing from this loop, whatever in my subarray, the subarray will be nice. So I will just take the length of this and maximize it by answer, and I will just increase the j plus plus, and I will just return my answer. So let's try to run it. Okay. Okay, my code is running on all the test cases, exactly correct. Let's try to submit it. Yeah, my code is passed, and it is giving the I bit only 12% in time complexity and space. So I will try to optimize the code further, but the time complexity of my solution will be O of n into O of 30 maybe at most, and our space complexity will be 30. That will be constant. So this is code of this question. Okay, let's end this video. I will see you soon.